Okay, so the purpose of this video is to 1. Draw the Lewis structures for each of these molecules, 2. Figure out their molecular geometries, and 3. Find out which ones are polar. So, step 1 is just overview of the procedure. A. Draw the Lewis structure. B. Identify the bond dipoles using the differences in electronegativities. C. Identify net molecular dipoles based on their molecular geometries. So, number 1, SO3. There's 24 valence electrons. First thing you want to do is put S in the middle and surrounded by oxygens on the outside. Then you want to fill up the oxygens with the octet rule, and then you want to give the sulfur an octet. When you move to your molecular geometry, it is a trigonal plane and the 2 oxygens on the bottom and 1 oxygen on the top. So all of the dipoles cancel out, so there is no net molecular dipole. For OF2, there are 20 valence electrons. You put two Fs on the outside of the oxygens. You surround the fluorines with their electrons. You give them an octet. Then you give your oxygen in the middle of an octet. So, since there are 2 non-bonding pairs, its domain geometry would be tetrahedral, but its molecular geometry is bent. So, given that there's no opposition or positive force pulling up, there is a net dipole, and this makes the molecule polar. For BeCl2, there are 16 valence electrons. You put both Cl's around the beryllium. Then you give each chlorine atom its electrons. The reason why there's no bonding pairs on beryllium is because beryllium is satisfied. It breaks the octet rule. Its molecular geometry would be linear, and its domain geometry is also linear. So both of the dipoles cancel out, so there is no net molecular dipole. Next molecule is CCl4 with 32 valence electrons. You put C in the middle, surrounded by the chlorines, and give each of the chlorines its octet, and the carbon its octet. The carbon is satisfied, and all the chlorines are satisfied. Now, I didn't draw the dipoles with the molecular geometry because it's a lot easier to understand it if you draw it on the Lewis structure. All of the dipoles cancel out because the molecular geometry is tetrahedral. It's not a trigonal pyramid, which would have led to a net dipole. So since they all cancel out, there is no net molecular dipole. Our last molecule is O3. Lewis dot structure on the middle, one on both sides. You satisfy each of the octet rules, which the one on the left has 3 non-bonding pairs and 1 bond. The one in the middle has 1 non-bonding pair and 3 bonds. And the one on the right has 2 double bond and 2 non-bonding pairs. The one on the right is the most satisfied. The molecular geometry would be bent. And because there is nothing to cancel out the 2 negative forces going towards the 2 oxygens, there is a net dipole, which makes this molecule polar. So the 2 molecules that are polar, if I could find, there we go. The 2 molecules that are polar are OF3 and O3. Thanks for watching.